Good evening, ma'am.
Right question from the previous class?
Yes, ma'am.
So you were able to solve or having any doubt?
No, I was able to solve.
The concept that today we will start with is yesterday we discussed about the
Ma'am, I
conductivity.
cannot hear you.
Yesterday we discussed about the conductivity and the molar conductivity.
Yes, ma'am.
Is the difference between them is clear to me? What is conductivity? Tell me. Kavya,
Ma'am, your voice is too low. I cannot hear.
this is true. Now is it clear?
Yes, ma'am. Better.
I was asking that the difference between the conductivity and molar conductivity clear to you.
Yes, ma'am.
So can you tell me that what is the difference between them? Just tell me that what is the difference between conductivity and molar conductivity. Kavya,
Hello, ma'am. Can you hear me?
sorry, what are you saying? Kavya, your voice is not clear.
Hello.
Kavya, yeah.
Yes, ma'am. Ma'am, conductivity is the ability to conduct in electricity in unit volume of solution, whereas molar conductivity is ability to conduct electricity by 1 mole of electrolyte.
Yeah, difference is clear.
Yes, ma'am.
Next topic that we have to discuss, the variation of conductivity, that is kappa, and molar conductivity, that is lambda m, with concentration. Okay.
Yes, ma'am.
First thing that we have to do is basically the conductivity. The kappa decreases with decrease in concentration. Why? Because kappa is the conductivity due to the number of ions per unit volume. Right? Kappa is the conductivity due to number of ions per unit volume. Is it
Yes,
so?
ma'am.
If I
Yes.
increase or if I suppose say I'm increasing the concentration, it means I'm increasing the number of ions.
Yes.
If I'm increasing the number of ions in the solution, it means the number of ions in 1 unit volume will also increase.
Uh-huh.
Okay, so if the concentration increases, then conductivity will increase. Or if the concentration will decrease, then the conductivity will decrease. Is it clear?
Yes, ma'am.
This is for both kappa decrease with decrease in concentration in both cases, either strong electrolyte or weak electrolyte.
Okay.
Okay.
Yes, ma'am.
Next thing is basically molar conductivity. Molar conductivity always increases with decrease in concentration. Why? Because when we suppose say I'm increasing the concentration. Okay. If I will increase the concentration, it means the number of ions will increase.
Yes.
If I am increasing the concentration, means the number of ions will increase. So molar conductivity is what? Basically the conductivity due to 1 mole of ions.
Yes.
Right? So now I will get 1 mole of ions in a lesser space, as the number of ions are too much, as the I have increased the concentration. Can I say this thing? If I increase the concentration, the number of ions in the solution will increase. So 1 mole of ions, suppose in firstly I was having 1 mole of ions in 10 ml water. Okay, correct?
Yes, ma'am.
So what is the molar conductivity? That is in 10 ml. But if I
Mm-hmm.
increase the concentration, means here I have added more number of ions. Now my 1 mole of ions will be, I found it in 5 ml,
Yes.
right? So in one mole, in the first case, my 1 mole is present in 10 ml. They are free to move. But in 5 ml, there will be a congestion, due to which they are not freely moving.
Okay.
Okay. So if I increase the concentration, then there will be a hindrance, or there will be steric hindrance, due to which my molar conductivity decreases with increase in concentration.
Okay.
Got it?
Yes, ma'am.
We will discuss this one by one in depth. First is the kappa variation, means conductivity variation. When we increase the concentration, number of ions increases. And if number of ions increases, kappa increases. Correct?
Yes, ma'am.
Because kappa depends on
Number of points.
number of ions per unit volume.
Yes.
Suppose before we have 5 electrons, and after increasing the concentration, I will be having 10 electrons. So that's why my concentration. Conductivity. Got it?
Yes, ma'am.
If I say that I'm doing dilution, what is dilution? What is dilution?
Decreasing the concentration.
Yeah. So decrease in concentration is basically the dilution. So if I'm decreasing the concentration, means the number of ions are decreasing and kappa will decrease. Clear?
Yes. Yes, ma'am.
If I say a graph for the kappa and concentration, I get a line, straight line like this for the strong electrolyte, and this one for the weak electrolyte. Got it?
Yes, ma'am.
In the strong electrolyte, I can see a sharp slope. Slope is sharp, but in the weak
Yes.
electrolyte, it is not so. Why? Because weak electrolyte do not dissociate completely.
Okay.
If weak electrolyte do not dissociate completely, then there will be a lesser number of ions. And if lesser number of ions will be there, then the conductivity will be lesser. That's why in the weak electrolyte, when the concentration is increasing, conductivity is increasing, but not up to that extent how much is for the strong. Got
Yes, I'm understanding.
Our next concept is basically the molar conductivity variation. Hardly one or two questions can be asked from these topics, and these will be direct one, like what will be the effect of increasing or decreasing. That like one of the parameter will they will change, and other they will ask that what will be the impact of it.
Okay.
Molar conductivity is basically due to 1 mole of solute,
Mm-hmm.
right? What we have
Yes, sir.
written that if I increase the concentration, my molar conductivity will decrease, right?
Yes.
If
Yes.
I tell you that what is molar conductivity? The conductivity per unit concentration,
Yes.
correct? If I
Yes,
tell
ma'am.
you, ask you about the concentration is what? Molarity,
Molarity.
number of moles
Molarity.
per unit volume.
Yes.
So can I substitute it over here?
Yes.
Okay. Molar conductivity is basically the conductivity per unit concentration. So number of moles will be 1 because I'm talking about 1 molar solution.
Okay.
If it is 1 molar, the number of moles will be 1,
Yes, ma'am.
correct? So, okay. So lambda m is now equal to kappa v. Got it?
Yes, ma'am.
If I say that I'm increasing the concentration, if concentration increases, kappa will increase,
Hmm.
correct? Because
Yes,
kappa
ma'am.
is directly proportional to concentration. But if I'm increasing the concentration, then my volume will decrease.
Yes, ma'am.
Right? So what
Hmm.
will happen with the lambda? Either it will increase or decrease.
Lambda will increase. So,
No.
so decrease.
Yes.
Decrease. Sorry, decrease.
Yeah. If concentration increases, lambda decreases because volume is the deciding factor in this.
Okay.
Okay. So if
Yes.
my volume is decreasing or increasing the concentration, then lambda will also decrease. That's why
Okay.
we
Okay.
say that if concentration increases, volume decreases, and lambda m decreases.
Yes, ma'am.
Okay. Any doubt?
No doubts.
Well, what happens with strong electrolyte? Whenever we have a strong electrolyte, it completely dissociates into the ions, right? So the molar conductivity graph of this with concentration is this. As my concentration increases, the lambda m decreases.
Okay.
Got it? So
Yes.
what I can say over here that it is a graph for a straight line. So there must be some equation for straight line, and that equation is lambda m is equal to lambda naught m minus a under root c, where lambda m is this one, lambda naught m, where this one is like this, y is equal to c plus mx. That is the straight line equation, where my c intercept is equal to lambda naught m and my slope is equal to minus a.
Easy. Yes, ma'am.
That is what I have done.
Yes, I'm understanding.
Now the thing is that what is this lambda naught m? It is this intercept. What is this A? It is a constant that is specific for specific electrolytes. It depends on what type of electrolyte we are using. We have many types of electrolyte. If I say that I am having NaCl, that NaCl will dissociate into Na positive and Cl minus. So it is one type electrolyte. If I say CaCl2, then it will dissociate into Ca2 positive and 2 Cl minus. Then it will be 2, 1. We write it on the basis of charge basis. So all the electrolytes that are of 1 type basis, whose cation and anionic charges is 1 will have the same value for A. And those with type 2 will have the same value for A, and the others with type 2 will have the same value for A. Clear?
Yes, ma'am.
So it is a constant, depends on type of electrode. Either 1, 1, 2, 1, 2, and
Okay.
one thing is there that when my concentration tends to 0, when my concentration tends to 0, then it means the concentration is 0 means infinite dilution will be there. Correct?
Yes, ma'am.
At that time, my lambda m will be equal to lambda naught m. This question can be asked in the exam that at what condition lambda m will be equal to lambda naught m. And in that question, most of the students write when the concentration tends to infinity. It's a common
Okay.
mistake that many students make.
Okay.
Okay, so at
Yes.
when the concentration is 0 means infinite dilution, and when infinite dilution is there means lambda m is equal to lambda naught m.
Yes, ma'am.
Got it? For the strong electrolyte, we can determine our molar conductivity. For the strong one, because the strong electrolytes dissociate completely into the ions. But in case of weak electrolytes do not dissociate completely, right?
Yes, ma'am.
So if the weak electrolyte do not dissociate completely, it will become quite difficult for us to determine the molar conductivity. So due to this, we use Holroche law of independent migration of ion to determine the molar conductivity of weak electrolyte.
Mm-hmm.
Okay. It is for weak one. What it says basically, it says that lambda naught m of weak electrolyte is sum of individual contribution of cation and anion of electrolyte. Got it? If I say that I am having NaCl, then the lambda naught m for the NaCl will be lambda naught of Na plus lambda naught of Cl. Got it?
Yes, yes, sir.
Any doubt?
No doubts here.
So, what happens in case of weak electrolyte basically? For weak electrolyte, our graph is something like this. It is like this. Means when the concentration tends to 0. Okay. Means infinite dilution will be there. Certain.
Yes, ma'am.
When infinite dilution will be there, we all know that the weak electrolyte dissociate completely in presence of water. So at what we can say that at infinite dilution,
Hmm.
or concentration tends to zero, there will be complete dissociation of weak electron. Can I say this thing?
Yes.
If there will be complete dissociation at infinite dilution, if I say that I'm having a weak electrolyte, suppose say acetic acid, so at infinite dilution, it will break into the ions,
Uh-huh.
correct?
Yes, ma'am.
If initially I'm having the concentration C for this, can I write this?
Okay.
After dissociation, it will be C alpha. Alpha is the degree of dissociation.
Oh,
We write it like this.
yes.
Here, tell me.
Nothing.
So Ka, degree of dissociation will be C minus C alpha, C minus C alpha, C minus C alpha. I have made some mistake. It should be
Ma'am,
C alpha,
C alpha, yes, ma'am. Why? That's.
right?
Yes, ma'am.
If I write it like this, it will be C square alpha square, C common, 1 minus alpha. It will be
Yes.
equal to C alpha square, 1 minus alpha,
Yes, ma'am.
where alpha is degree of dissociation. Correct?
Yes, ma'am.
So this is the thing that we calculate the degree of dissociation. But the degree of dissociation can also be found out with the help of molar conductivity. It can be written at like lambda m divided by lambda naught m.
Okay.
Right? So if we substitute alpha in this form, then can I write it like this? Lambda m divided by lambda naught m square 1 minus lambda m divided by lambda naught m. Correct?
Yes.
And I can write it like this. C lambda m square divided by lambda naught m minus lambda m.
Uh-huh.
Right? So with the help of this now, you can find out the degree of dissociation, that is alpha, by using lambda m divided by lambda naught. And also you can find out the value for Ke. Got it?
Yes, ma'am.
Any doubt? One more thing. If you have any saturated solution, for any saturated solution, when we have a saturated solution, what is the saturated solution?
When the solvent cannot take any more solute.
Yeah, it means the amount of solute is very, very greater than the amount of solvent.
Yes.
If the amount of solute is very, very greater than the amount of solvent, it means my solution is too much concentrated.
Yes.
Is it so? So,
Ma'am, take it.
yeah.
No, I'm listening. Sorry.
So for any saturated solution, lambda m is always equal to lambda naught m. Right?
Yes. Okay.
So one thing is this. Next thing that we have to do is the Colruy's law. The question mostly came from that. That if you have to find out the lambda naught n for any weak electrolyte, so what you will do, you will sum up the lambda naught m for the individual ion space. Just for example, like I have to calculate the lambda naught m of calcium chloride. That I have to calculate. It is a weak electrolyte. So I know that calcium chloride will dissociate into Ca2
1 and 2.
positive and 2Cl minus. What
Yes.
I will do, lambda naught m for CaCl2 will be equal to lambda naught m for calcium plus 2 times of lambda naught m of chloride. Got it?
Okay.
Any doubt?
No, not here.
Then tell me what will be the lambda naught m. These values will be given to you directly. So you have to put values in that and you will get the numerical value.
Okay.
Lambda naught m for magnesium sulfate. How will you get?
We have to do the same way, right? Lambda not m like I said.
Yeah, so what will you write this?
So MgSO4 is Mg2 plus SO4 2 minus.
Hmm.
And then lambda not m on both the sides.
Okay, so lambda naught m of Mg2 positive plus lambda naught m of SO4 2 minus will be equal to lambda naught m of MgSO.
MgSO4.
Correct?
Yes.
Now do just one more question. Conductivity of 0.20 molar solution of KCl is that at 298 Kelvin is 0.0248 Simon per cent. So calculate its molar conductivity. Just do this much. You Kavya, tell me one thing that you know about the synergistic effect.
Sorry, ma'am.
Do you know about the synergistic effect?
Ma'am, your voice is low. I cannot hear you.
Do you know about the synergistic effect, the bonding in carbonyl complexes?
Yes. Synergy effect. Yes, I have a basic idea.
Okay, actually that part has been left from the coordination compounds. So that's why I asked.
Yes.
Do you
But I have a
want
basic.
to?
I have a basic idea. मतलब basically, the ligands will share electrons to the central atom, right?
The carbonyl ligand will donate the electron pair to metal, and the metal again
We
gives
will
back
donate
the
one.
electron to carbon by making a pi bond.
Yes, ma'am. I have a basic idea about it.
You have the idea, so no need to do that.
No, no need.
Okay. After electrochemistry, you are left with the blocks only, huh?
Yes.
In blocks D and F,
Yes, ma'am. D and F.
and S and P.
S is actually we didn't study S actually. P I
Okay,
have
so
a
it's in your
little idea about.
syllabus and S and P or not?
I think advancement is there. S.
Okay, not in the mains, huh?
No,
Sorry.
not in it.
Okay, in pre it is not there, but in advanced it is there.
Yes.
Okay, after this chapter we will do the D and F.
Mm-hmm.
Other chapter than this, so that I
No,
can plan accordingly to complete your syllabus. Huh? That's why I'm asking.
no, the chapters. No.
Okay.
Ma'am, can you do this problem? I'm unable to solve this.
You are not able to do.
Yes, no. Can you solve this one?
See, what I'm giving here is the conductivity. Concentration I'm given is point this one. Conductivity is this one. Means kappa is given to me. That is 0. And see the unit for kappa is this one. Calculated molar conductivity. But in the last class, you have done the question that is more difficult than this question.
Yeah, this one I'm remembering.
Is it clear? We know the
Yes, ma'am.
formula, that is lambda m is equal to 1000 into kappa by C.
By M. Yes.
See, now, when the unit is in Siemens per centimeter. So kappa
Hmm.
we know, C we know, the lambda m will be calculated.
Yes.
Correct? Clear?
Yes, ma'am.
Well, so here we have completed the electrochemical cell. This chapter we have to learn two things, no? The electrochemical cell and the electrolytic cell. Where chemical energy is used to
Ma'am,
generate
your voice is
electricity.
coming.
So first one was the electrochemical cell, where chemical energy is used to generate the electricity or the electrical
Yes.
energy. That part
Yes.
we have completed.
Hmm.
So next part that we are left with is the electrolytic cell. What is electrolytic cell? Where electrical energy is used to get chemical energy. Got it? Or we can say that the non-spontaneous reactions basically. The non-spontaneous reactions that we cannot do without by ourselves. We all have done this in electrolytic cell. Like in the previous one, in the electrochemical cell, what was happening? A chemical reaction was running on its own,
Mhm.
right? And we were getting the electricity. That's why our bulb was going. In this case, we want to have a chemical reaction, but that is non-spontaneous. So that's why we need to give some electrical energy to this so that our chemical reaction proceeds. Are you getting?
Yes, ma'am.
Okay. So these types of cell are basically the electrolytic cell in which a non-spontaneous reactions needs to be done with the help of external source. So these are basically the non-spontaneous reactions where external source of voltage is used to bring chemical reaction. Okay.
Yes, ma'am.
If my reaction is non-spontaneous, it means delta G will be
Positive.
positive. It means it will be greater than 0.
0.
Correct? So we have learned that the basis for electrochemistry is the redox reactions, right? In the electrolytic cell, what we have to do basically when we apply the electrical energy or external voltage. Okay, so that external voltage that we use is used for electrolysis. The external voltage that we apply is used for electrolysis. Okay, what is electrolysis basically? Electricity is used to break down something. Electricity lysis means breakdown. Got it? Means
Yes, ma'am.
electricity is somewhere used to break down something, and that something is the chemical reaction basically. Or our chemical reagents, we are breaking the chemical reagents to have our chemical reaction.
Uh-huh.
Got it?
Yes, ma'am. Yes, ma'am.
Electrolysis, basically we have two types. One is the quantitative one. Second one is the qualitative. In the quantitative one, what we have basically the amount of product that is formed at the electrode. Means how much is the product that is deposited over the electrode, and like this, the amount to be calculated. That weight you can say. In the qualitative, basically, the products formed by electrolysis. That, like, what are the products that are formed? You can see the products formed by electrolysis at electrode. In qualitative, that what are the products, and in the quantitative, how much is the product.
Okay.
Got it?
Yes.
Basically, we study generally the two applications of the electrolytic cell. First one is the purification. You can purify any metal with the help of electrolytic cell. Purification of metal, we can. Okay. Second one is the electroplating. Right? We can plate any metal over the one metal. Okay.
Yes.
Now we'll do that. What actually happens in electrolytic cell? In the electrochemical cell that we studied about the Daniell cell, we were having the two containers that we call as half cells.
Mm-hmm.
Right? In electrolytic cell, we have only a single container. Got it? In this container, first one we are doing over here, that is the purification of matter. Okay? In this,
Mm.
we place two electrodes. One is the anode and other one is the cathode. Got it?
Yes.
We have learned that on anode there will be oxidation. Means I have take like I want to do the purification of metal of copper. So if I have to do the purification of copper, so the electrolyte that I have to use should be of copper. So I have taken the copper sulfate. Okay. Got it?
Ma'am, it was yes, ma'am.
My anode is the one I want to do the purification basically. So the impure electrode I have taken over it as an anode. Okay. So on anode, what will happen? There will be oxidation. Are you getting?
Yes, ma'am.
So what happened over anode? There will be oxidation. So the copper that is in impure electrode basically. So that copper will convert into copper ions because my electrolyte is copper sulfate. So the copper ions from this electrode will go into the solution. It is the same that was happening in the Daniell cell. In the Daniell cell, it was zinc in place of copper.
Sorry, can you repeat, ma'am?
In the Daniell cell, it was zinc at the anode that was converted from Zn to Zn2 positive. And in
Yes.
this case, we are having impure electrode from where copper is getting converted into copper ions and getting into the electrolyte.
Yes, ma'am.
Correct?
Yes.
So we are left with electrons over anode. So our anode is negatively charged.
Yes.
So we will connect it with the positive terminal of PET.
Okay.
So this should be in your mind that the anode in electrolytic cell is always connected with the positive terminal of a PET. Clear?
Yes, ma'am.
So now what happened basically, the copper from impure electrode goes into the electrolytic solution. Now what happens at the cathode basically? The copper ions from the electrolyte solution will deposit on the cathode. Is it
Yes.
so? So what I am
Yes.
saying that copper from the impure electrode is getting into the electrolytic solution and getting deposited over the cathode. So from the impure electrode, I am getting the pure electrode over cathode. Because on the cathode one, I will have only the copper one that is deposited. Any doubt?
No doubt, sir.
Clear? So this is the process by which the purification of metal takes place.
Okay, ma'am.
Okay. Next is my electroplating case. In this again, I will take a beaker. Okay. Place two electrodes. One is the anode. Other I will take a glass. Suppose say I have to electroplate my glass, silver glass. So I will make it as a cathode. It will be like this. Got it?
Yes, sir.
Suppose I have to electroplate my glass with copper. So I will take copper sulfate over here and a copper electrode over here.
Mhm.
Because I have to plate copper over my glass.
Okay.
This is a glass, steel glass. Okay. So what will happen in this case? Copper from the copper electrode, copper ions will go into the solution. Because at the anode there will be oxidation now by
Yes,
the
ma'am.
trick that is anox at red cat,
Yes, ma'am. Yes, sir.
right? So there will be copper ions in the solution and these copper ions will get deposited over here. As on the cathode, there will be reduction. Correct?
Yes, ma'am.
So copper ions from anode goes into electrolytic solution and copper ions from electrolytic solution deposits on cathode. Got it?
Yes.
Basically, these are the concepts that actually happen in case of electrolytic cell. Okay, just tell me that in what condition my electrochemical cell behaves like that of electrolytic cell?
Uh, when the voltage is when the external voltage is less than the
Less nay greater.
generator. Sorry, huh?
Okay. So what I
Yes.
am seeing over here that I'm using a voltage and that voltage is used to have this reaction process. This is my external source. And in that case, we were not using any external source. There were the wires and a bulb. It was like this in the Daniels, where chemical energy is generating the electricity to have that bulb glow. But in this case, we have the battery that is used as an external voltage to have this reaction. This is the major difference between the two cells.
Yes, ma'am.
Got it? Just have a quick revision of this.
Okay.
Do I need to scroll down?
One second, ma'am. I'm reading this.
Do you have these notes? You are able to scroll down these notes.
No, I'm not.
Then how are you?
No, you told me to revise that other cell, right?
Yeah.
You told me to revise the other cell, right?
Other?
Other cell, the first one. Electrochemical cell.
No, I told you to revise these ones. Today's class.
Acha, I was revising that. Okay, sorry.
That you will revise on your own, and if you find any doubt, then you can ask.
Okay, okay.
But now it's the time to revise this one.
Okay. Yes,
Just tell me then whenever I need to.
yes, ma'am. Yes, ma'am, we can slow down a little. Yes, ma'am. Slow. Yes, I'm slow down. Yes, I'm a little more.
What?
Yes, I'm down, ma'am, down. Ma'am, can you go down a little?
Can you
Can you scroll down, ma'am?
scroll down?
Yes. Yes, ma'am.
Are you finding any improvement for this chapter after having classes of this chapter? Or it is same? Like,
Ma'am, like I'm solving university, so I can do some problems now at least.
but before that you were not able to solve them.
No. This chapter I didn't really study about it.
Okay. But now at least 50% is clear to you. Now
Yes,
you are
ma'am.
able to understand the question, like what is has been asked in the question, and at least you try that what you have to or what you have been asked.
Yes, ma'am. Yes, ma'am. Scroll down. Scroll down, ma'am. Down. Yes, ma'am.
In the Kulraj law, na, always remember that we have to use this one also. This is the stoichiometric coefficient.
Okay.
Actually, these simple questions, sometimes these can also be asked. And some students forget to use this one. They simply write that delta naught for calcium plus delta naught for chloride. That common mistake been found in the exams.
Yes, I'm down. Yes, ma'am. Yes, I'm down. Done, ma'am.
Well, this is the qualitative part basically. Qualitative part of electrolytic cell. The quantitative part that we do in the next class. And tell me one thing, that the part of batteries, fuels, that you also want to do?
Ma'am, I don't know. Is that important? So if you can do it, will be nice.
At least sometimes questions been asked. So I will teach you that whatever it is.
Okay.
Okay, I will tell you the important points from that part.
Yes, ma'am.
Okay.
Thank you, ma'am.
Okay.